This is a quick video to introduce you to index laws. So what are index laws? What even is indexes, or what are even indices? These are all big words that have got some sort of meaning or other. Well, indices just means more than one index. And what do we mean by an index? Well, that is another way of saying to the power of. So for example, if you've got 3 squared, so 3 with a little 2 on top, that's the same as saying 3 to the power of 2. The little 2 at the top goes and it tells you how many times you should multiply that number by itself. So if you have 3 squared, 3 to the power of 2, that's the same as saying 3 times 3. If you had 3 to the power of 3, that'd be 3 times 3 times 3. If you had 3 to the power of 4, that would be the same as saying 3 times 3 times 3 times 3. The first of our index laws looks something a lot like this. It's called the adding of powers. If you have 2 numbers of the same base multiplied together, you just add the indices. Now what does this even mean? So, what we'll do is I'll grab my markers here. The big number at the bottom is what we call the base. All our bases belong to us. There we go, there's some bases. And the little symbols at the top here, that's the index. That's also an index there, or indices. And what happens is if I've got 2 numbers, same base, with different powers, or could even be the same power, doesn't matter, I just add them. So let's go and look at a practical context. So, why does this even work? Well, I'm going to start by looking at this example. What is 3 squared times by 3 cubed? So 3 squared times by 3 cubed, using my index law, would be the same as saying 3 to the power of 2 plus 3, which would be 3 to the power of 5. And that's all nice if you don't want to think or anything like that and you just want to believe everything I say. But let's go and actually look at it from a proper context. So, what does 3 squared actually mean? Well, that's 3 times 3. 3 times 3 is 9. That's right, 9. What's 3 to the power of 3? Well, that's 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 must be 27. So now we need to do 9 times 27. Now, unless you're some kind of genius of some kind, I'm sure you could possibly do this in your head. Alternatively, what you would do, 27 times by 9, 7 times 9, 63. 2 times 9 is 18. 18 plus 6 is 284. So 243. You'll notice there I wavered a little because sometimes when I do these videos I think, did I get my timesing right? 243. So what I want to do is I want to demonstrate to you that 243 is the same as 3 to the power of 5. So let's go and determine this. 243. What we need to work out what's a couple of numbers that fit inside, otherwise known as factors. Factors are numbers that can divide evenly into another. So 243. Well, let's go and see. Well, we already know that. If I didn't know my little multiplication here, 243. Let's say divided by 3. What's 243 divided by 3? So it's 3 times. 3 goes into 24 8 times. 3 goes into 3 once. It's 3 times 81. That's handy. Can any numbers fit inside 3? No, just one in itself. It's what's called a prime factor. A prime factor means that only itself and the number 1 can fit inside. So 81, what are 2 numbers that can go to 81? Well, that would be 9 times 9. And what's 2 numbers that can get inside 9? 3 times 3. 3 times 3. So, if I look at all this, 3 times 3 times 3 times 3 times 3 is equal to 243. Well, three times 3 times 3 times 3 times 3 is the same as saying 3 to the power of 5. Therefore, we have proved that 3 to the power of 5 is the same as 243 by dividing out and turning into the factors. So in summary, if I have two numbers of the same base, I just add the power.